Cool.
Yeah, thanks, Susie, and thanks everyone for coming along. We are Kai Lab. We are the three members. We are an art collective based in East London, and we work a lot with light, sound, and motion. And we develop a lot of tech here in our studio to power our own artworks and to control them. To kind of develop new ideas there. So we do a lot of our own work, and we also collaborate with other artists and designers, doing kind of technical consulting on their projects as well. But today we're going to mainly be talking about a few pieces that we. So I'll just start off by speaking through our general process and how we kind of work as a collective. The three of us have backgrounds in physical sciences, and a lot of our work is looking at natural patterns of movement and natural phenomena. And so we often kind of start our ideas in a research phase. So for example, you can see it on here, this is looking at natural resonance frequencies in plants, but this can be a range of things that we see in the world and we read a bit about and we talk a bit about and we think a bit about. And once we've done that initial research phase, we start prototyping and experimenting in the studio with ideas. So that could be a range of things, but we build little models and we tweak, and if we find something that we are really taken with or we think that could become a really nice piece, we'll develop that more formally in what is often immersive interactive works. These are at a range of scales. We'll be talking about it. So Marguerite will start on those now.
Yeah, I'm just gonna kind of give a bit of an intro on what we're going to talk about today. Just in case you can't see properly the videos, if the screen sharing is not working properly, there is a couple of links that have been sent in the chat. And so if you kind of click through them, you should be able to find the one we're looking at. So we wanted to pick a couple of works today that kind of we have developed from research that we've done on the idea of phases in a kind of quite mathematical and scientific way, I'd say. As Ruby was mentioning earlier, a lot of the phenomena that we observe and that we're interested in are natural, and often those natural objects are things that are vibrating or oscillating in specific ways, and that create really interesting patterns. And so we're going to present three pieces, each of which is kind of evolving around this idea of different types of phases, and I'll explain a bit more clearly what we mean by that. One of them is a kinetic sculpture. The second piece that we're going to talk about is a sound installation, and the last piece is a light artwork. So to explain a little bit what I mean by phases, I've shown here, this is a simulation of one of the first pieces that we're going to talk about. And what you can see in this simulation is that each of the modules is oscillating back and forth. And they're all oscillating with a similar frequency, but they're all shifted. The phase of each one of those oscillations is slightly different for each of them. They're all starting the cycle a little bit later than the one next to them, which means that, as you can see, it creates this sort of illusion of a wave passing through the sculpture. But there isn't anything actually moving physically from one point to the other. It's simply a sort of an illusion of movement, which is what we call a wave, I'd say. And that's what we find really interesting, I guess, in the phenomenon that we see around us, is how lots of objects, lots of modules oscillating and vibrating in a similar way, but at a different phase or at a different frequency, can create emergent patterns, and that creates a really unexpected kind of aesthetic outcome. So we'll talk about that a bit throughout the three pieces that we're going to present today. And I'm going to let Sean introduce our first piece, which is called Honami.
Yeah, so Honami is one of the first works we did together, actually, I think. and it's named after, I think it's both the English and maybe just the Japanese word for the effects that you see in a wind-blown field of grass. So maybe the video is working for you now, but maybe it's not. But I'm sure you've all seen like a field of really long grass with wind blowing through it, and when you have the gusts of wind, they create this kind of seemingly like a wavy surface. It almost looks like water sometimes. And the wave effects that you see traveling through that surface are emerging from this kind of phase shift. So you imagine that each blade of grass is just kind of swinging back and forth in the wind on their own independently. And then all of the blades together as a whole system create this wave pattern. So that's what we're talking about when we refer to emergence and phase shift. So we wanted a way to, so we've seen this kind of pattern, and we find it really, really interesting to look at, and also super soothing to watch. And we wanted a way to like kind of capture this in a so we decided to take a kind of one-dimensional snapshot of the blade of grass, imagining it can only move in kind of one axis of motion, and then attempted to replicate this using kind of hardware materials and motors and electronics. So here you can see a picture of the first form in which this piece is taken, which is made out of 20 of these modules that are made of CNC plywood, and each of these triangles can rotate, move back and forward to create the wave-like patterns with the motor. Yeah, so here you can see a video, and again, if this doesn't work super smooth, you can click one of those links and check it out with Vimeo later on. Also, sorry about that noise. There's a motorbike outside. Yeah. So here in the work we have there's a computer controlling each of these blades, and there's like a sort of simulation of how gusts of wind would blow through the sculpture, and you can see each of the modules individually is just rocking backwards and forwards at a frequency, but with the different phases of all of them shifted, you see a wave pattern traveling through. Also, we find this really interesting because you can kind of create the sense of motion, or a really large sense of traveling motion in a space with not necessarily that large kind of kinetic items. So all these pieces pack up into the back of a van, but you can scatter them out over a large distance and still get this sensation of traveling wave over. Yeah, so we've shown this in a few different places. This picture is of it shown at Collider Festival. So here it was suspended above the members who were like coming to this festival and watch it far underneath. And when we ran it here, it was just the patterns in the sculpture were created by a sort of wind synthesizer. So it was kind of like a playback, almost like a kinetic video, I guess, of generative gusts of virtual wind blowing through the sculpture form. But we've also shown this in another context in which the presence of people could create those gusts. We had a number of sensors along the sculpture and detect people coming close to it, and close proximity meant a large gust of wind, and you see that kind of travel down the line. So we've been recently experimenting with trying to make this on a much smaller scale. So we wanted to sort of come away from the large, I guess, bulky approach and try to make a really delicate, small version. But we found it really, really hard to figure out a way of making smooth oscillating motions with electric motors and stuff in a way that's, you know, moving smoothly, free of jitter, but also without creating any noise. So we searched for a long time and couldn't find anything that could do this, and ended up kind of coming to the conclusion that the best way to approach this was by building a sort of metronome device that swings backwards and forwards, but it's actuated with electromagnets. So here you can see a picture of a little prototype of that. The coils on the left and the right would swing a sort of pendulum backwards and forwards. So yeah, we designed a small-scale mock-up of a kind of series of these swinging pendulums that would be stacked in a line. Built up all the components to make that movement work the way it should. But here you can see a photo of all the coils lined up. So each of the modules has a little coil that can swing two coils actually that can kind of alter a magnetic field with a certain frequency, and then the idea is to oscillate them back and forward, but each one has a different phase and you get the same sort of effect, but much more delicate and totally silent as well. So here's a video of kind of where we're up to with that at the moment. We're able to sort of get the wave-like patterns happening, but at this stage we're not yet able to get it to kind of create differing gusts. So one thing we'd like to be able to do is create a kind of series of different gust intensities, not just have it kind of oscillating the same all the time. So, have it settle down and stop moving at all, and then like occasionally a gust will blow through. Yeah, it's super exciting to kind of move forward with that piece. And then I think Marguerite's going to talk about the next one.
So the second part of that group of work around the other phases is a sound piece called clickers. I guess the way we like to describe this installation is that it's an ecosystem of lots of modules that react to environmental light and create polyrhythmic soundscapes. I'm just going to try to explain a little bit how they individually work. So each of these modules is completely independent, and each of these triangles that you see is one little plant, one little module. They have a light sensor, so they detect the intensity of the light in the room. And on each of those triangle of paper, there is a piezo, which is a little membrane that vibrates when it receives an electric signal, and a little LED. So the interaction that each of these modules is going to have with the light is very simple. It's simply the brighter the light is in the room, the faster the click that the membrane is emitting is, the faster it is. The brighter the light, the faster the click. So if you're in a really bright light, you have lots of little clicks happening all around if you have lots of clickers around you. And in a really low light, those clicks will happen quite infrequently. And that's a shot of the piece from above where you can see the triangles and the clickers and their little LEDs. And I guess what's interesting with this piece is this idea that we can't really predict what the pattern is going to be like, but it creates this really meditative experience and quite unpredictable patterns of sound and light kind of evolving depending on the light in the room. And what I wanted to mention as well is that what's really interesting is that each of these clicker, it may seem that they will all react identically to the surroundings. If we're on like really low light, the eye is going to perceive the light around us being exactly the same, but effectively each of these little sensor is going to pick up slightly different variations of light because of a shadow of a nearby clicker or because of a light that's being turned on. And so each of the oscillations of the clicks and the lights is going to be different, and you get these phase shifts that we've been talking about in Honami. So it's a similar idea, but that creates a really complex kind of chaotic soundscape and lightscape. I don't know if that's a word, but around the visitor, I guess. And create this quite meditative experience. So we prototyped this work a couple of years ago and only kind of took it into production kind of phase earlier this year. So we first built them with little analog components. As you can see here, they're all like handmade, soldered on little chips and resistor, and it took quite a long time to build just one of them. But we wanted to really keep that aesthetic of raw electrical material. And we really like to work with brass because it's really a very flexible material in terms of the uses we can get out of it. It can conduct electricity really well, so we use it to send signals. We use it as a structural piece of the work, and it can be quite delicate and serve as a sculptural function as well. So we developed a new version more recently, which is a little bit faster to assemble, but it's still quite a lot of work. It's all those little circuit boards that you see here are effectively doing the same interaction and the same behavior as the previous prototype, but we can build a lot more, a lot faster. And here's a picture of a few of them together. So we're trying to ideally build a couple of hundred of them. So it would still take a while, but hopefully we can get that happen. And I'm going to show two videos. I don't know if the sound is going to work through screen sharing, but you should get a link to clickers on the chat if you want to watch it in your own time. And what's interesting is that you'll hear different types of behavior of sound depending on the intensity of the light in the room. So if the light is bright, not very bright, but it's relatively bright, the clicks of each module of each clicker is going to be quite fast, and it creates this effect of almost like cicadas, a field of cicadas around you. So this kind of chaotic, quite fast little clicks everywhere. But then in lower light, the sound is more sparse and it's moving around a lot more slowly. So I'll show this first video. But just to give you an idea, and this one is really like in very, very, very low light, the sensor still gets little bits of light, and they can, they're still reaching some like a specific frequency. But what's interesting is that you get this like patterns of light and sound really clear that move around the piece. Yeah, when we build that first, like the first prototypes, we really wanted to know if it was possible that they all click together, and even if it's very, very not probable because of how they function, there is this kind of when you watch the piece, there's this kind of wait. We're like waiting for them to all synchronize, that all their phases are going to maybe meet, and then they will all click together. That might not ever happen, but if it does, we wonder if it's going to be very loud. So we're still waiting for that. And of course, the more we build, the less likely it's going to be for them to all click together, but we still want to build a lot because I think it's really quite beautiful. I'm going to pass on back to Sean, who is going to talk about our last piece that we've been working on quite recently during lockdown.
So this next piece is called Sinusoidal Noise. Sinusoidal noise. Don't really know how to say it. And as the name suggests, it kind of is what it is. Like it's a very similar concept to clickers, actually. So the idea here is that you create a kind of single pixel module, and all that module does is fade on and fade off a light at a certain frequency. And then when you arrange these in a grid and alter the frequencies of them all slightly different, so that each frequency, each module is slightly different from the other you get this noise pattern, and it's different to kind of white noise or chaotic noise. They're not flashing on and off randomly. They're fading on and off with a sine curve. And the emergent patterns that you see here are, or you can see sometimes, not necessarily in this simulation running here, are kind of more like moving patterns or traveling waves, actually. So it's sort of the same idea as the wind-blown grass, that there's no gusts of wind here. It's just this random chaos. But sometimes you'll see a group of pixels sort of flow across the screen, or like a line of them fade on and off in sequence. So here in the simulation, you see at the beginning, they all start to fade on at the same time, and then very quickly they fall out of phase because they're different frequencies, and come in and out of phase again. And actually, the same as clickers, there's this probability that at some point they'll all turn on again in sync, but it's also very unlikely, but maybe a hyper satisfying moment to look at.
And very bright.
Yeah, super bright. Anyway, so yeah, we wanted to find a way to make this, and make it within the confines of lockdown and, I don't know, minimal budget, I guess, just basically using leftover stuff that we had in the studio. So we designed this little circuit board it's just an oscillation circuit that just fades the light on, fades it off at a specified frequency. But after testing a few little prototypes of this circuit, we found out very quickly that you don't even need to actually program the individual modules to oscillate at a specific frequency different to the adjacent ones. You can build them all identical and then rely on the sort of manufacturing defects, or the differences, slight differences in the component values within manufacturing tolerance to give them a slightly different frequency of oscillation. So we ended up building all the circuits with exactly the same components, and just because of this discrepancy in the component values, you do get them falling out of phase and back in phase and stuff. So they all oscillate at slightly different frequencies. I guess the next thing here is we wanted to figure out a way to make a really nice quality of light, like a really nice pixel to look at. We wanted to kind of hide the LEDs that we were using to create the light, and create something similar, or in vogue at least, to the James Turrell works. So you can create these amazing spaces where you can look into them and have no idea how big they are because of the uniform light distribution everywhere. It's like all the light reflecting off the wall is exactly the same brightness level everywhere. And your eyes kind of get freaked out and can't tell the difference between where the wall is and where infinite. So yeah, we took inspiration from this and tried to replicate our own tiny little James Turrell bucket. So yeah, the idea here was to hide the LEDs and make them project onto a surface in some way and reflect light off that surface in a totally uniform way. So we wanted the pixel, when you looked into it, to not have any identifiable corners or edges or depth, say, and give you that totally uniform brightness. So here are a few sketches of the kind of early idea. The one in the center, you can see a cross section of pretty much the latest version of the pixel, where the LEDs are positioned kind of off the side and the light reflects around the corner and fills up this bucket of light. So it's like a kind of light bucket, and then you view it through the hole. Kind of, we should have put an arrow here or something, but down through where it says pixel width, you'll be looking down through that hole. Yeah, and here's a kind of picture of that coming together in the real world. So we managed to 3D print the little bucket, and with many coats of spray paint, get a kind of uniform matte white color as a reflection surface. The circuit board that we made is underneath that, and you can sort of see a little LED bulb there that hides underneath the bucket. And what's not shown here is the outer walls, which actually reflect the light into up and around the bucket and into it. flow. And yeah, again, we're using brass here just as a kind of functional, strategic thing to pass through the power to each of the individual modules. Yeah, so we decided to build a version of this that had 98 pixels. I think it's 7 by 14 or something like that. Anyway, it was a reasonable size, kind of within the realms of what we could make here in the studio and like what we had the patience for with 3D printing and stuff. Because if you print one of these buckets, it takes a certain amount of time to print 98 of them. It takes another massive amount of time dealing with the circuit boards and all that stuff. And then this is the picture of the piece. So you're looking front on into that light bucket, and not see the individual LEDs, and it's not like a diffused surface. It's like you're looking into a hole. It's not. It looks like it's there, and then when the light turns off, well, especially in a really dark environment, the light turns fully off. You get this ultimate contrast. It's very different to looking at a screen or some sort of diffused LED, because you can't see the surface when the light's off. It's just like you're looking into a void. Similar to, kind of like a Manta Black style experience, I guess, in really, really dark light conditions. And here's a little video of the lights fading on and off.
That's actually quite bright light too, so that you get an idea of like what the piece is.
Yeah, and then
next dimension. Yeah.
The next video, unfortunately, we realized when we turned this on in full darkness, it looks extremely similar to the simulation. Videos of it. Yeah, not the real life experience is really cool, but yeah, to capture it on film, that's not the simulation. Yeah,
we have a proof of it, which is this. So here, that's just from a view from the side, so you can see the light, the kind of like brighter light that you see. That's the actual external wall, so that's the light reflecting from that wall, and then you can see the bucket that's a bit less bright. So I guess you can see it from different angle. We imagine it to be viewed from straight on, where you really cannot tell where the edges are, and you get this weird pixel kind of coming at the surface to you, which is really hard to film, and so you will have to see it live to understand.
And the contrast there is, it's really obvious here. You can see when the pixels turn off, they don't exist anymore, especially if there's no light coming in from the front on the front face. Yeah. I think that's all. That's all of the phases concepts that we've been working on.
Yeah. I'm going to stop sharing the video.
Yeah. Hello. Thanks so much, everyone. Do we have any questions? I think everyone should be unmuted now. But you can unmute, just be able to unmute yourself. I'll kick off with a question. I'm interested in your collaborative process and like how you kind of delegate between your different skill sets, or do you kind of all kind of share the roles quite evenly, or do you know what I mean? Do you have like particular roles within your projects?
Yeah,
it's a mix. We all do a lot of different things, so I feel like we can share a lot of the work in different ways. I guess we have some sort of different expertise. John does a lot more like robotics, mechanical, like design engineering, and all the kind of really hardcore electronics. I guess I would delegate to him, and Ruby would do a lot of all the production process and like all the kind of managing and more like logistics side of things, and I would maybe do a bit more like spatial design and all the media stuff. But I think we all take part into like the production and design in different ways. Like sometimes I do the programming and the electronics, and Sean is like drilling things, and then Ruby's like painting things, and we share a lot of of
Yeah.
the work, which works really well. And then the creative process is a bit different, I guess, in the kind of actual designing.
But yeah, in production mode, we're all hands on deck, just everyone
Yeah.
drilling. Everyone's sanding and drilling.
Do we have any questions from the audience? I don't know why everyone's videos are muted today for some reason. I'm not quite sure why. Normally we can see people. But I don't know. Yeah, if people want to turn their videos on and and unmute yourself if you have a question. Yeah, strange. I don't know why it's being like it is today. But Karen, do you have a question?
No. I just thought it might be nice to see another face.
Yeah, I don't know what's going on. Normally we can see people. I've got more questions, so I'm just going to keep going. Like, I was just interested in kind of how much you've observed viewers interacting with your work at maybe situations like Ugly Duck in Bermondsey or Collider Festival. Like, did you kind of have interesting conversations with people interacting, or how much have you like tested that out after you've finished the piece? Kind of a strange question, but like not a very concise question. Sorry, multiple questions in one.
I guess there's the thing with interactive works, mate. Like, I mean, in my experience at least, you often think there's the greatest thing in the world in your mind. You know how to interact with it, but other people maybe don't get it, or they don't understand how to interact with it. But something like Honomi at Collider, people they enjoyed looking at it. They thought it was soothing, and I think I guess it's really important to us to go and see what they have to say about it.
Well, I guess the specific works that we were presenting now are like, I guess they're quite soothing and quite not like you wouldn't really necessarily interact with them specifically, or they would be quite subtle in a room or in a space. So, for example, Honami, we installed it in a cafe, and it was above people passing by, and I think you notice it if you like sit and look at it, but it just creates some sort of atmosphere in the space. Mm-hmm. So it's less of a direct interaction, but then there are other works that are more directly interactive, that are more like sound light interaction that we didn't present, and it's really interesting because we come from like a very scientific or technical background, and we understand the interaction in a way that maybe other people don't, and it's really interesting to hear what people think, because sometimes I think we are trying to achieve when it is interactive work, that people don't need to understand how it works at all, because we just want them to appreciate the experience of it. Mm-hmm. Which is why we try to keep things really, really simple. But sometimes it's not simple. Depends how it's built. But yeah. I guess we need.
Oh, sorry. I was just going to say, do you find that the simpler works in end result are often the more complicated behind the scenes?
I think it's interesting also. Well, people have like really high expectations of what technology can do now, so they don't think there's like an element of seeing something that's technically really complex and not understanding what's behind that. So I think that's quite interesting to see as well.
Yeah, but I don't know, simpler works being complicated. I think everything's complicated when you try to do, like, you're just finishing anything with, like, if you're dealing with, because I guess a common theme that you must have seen in our ideas is we have like, you build one simple thing and then you try to replicate it loads of times and turn it on, but it's never like that, because a good example of this is the sinusoidal noise. When we first turned this on, all of the pixels were oscillating, but they all stayed in sync, and we were like, what's going on? Like, when we tested this with 4 pixels, they all were falling in and out of sync, and what was going on? They're all like kind of synchronizing with each other, and it was a sympathetic resonance thing. Like, I don't know if you've seen that experiment where you sit metronomes on the same surface. Even if you start them out of time, they'll all go in sync with one another. And it was the same with the voltage from the power supply was dipping in time with all the lights being on. And as a result, they would all sync with each other. So, we did some electrical edits to kind of mitigate that problem. But yeah, something so simple just goes to
Yeah, we get often surprised how like something can work perfectly and appear really simple, and it's like great, it's going to work until the end, and then there's just something that we don't understand that's happening, and it's amazing because then we get to understand how the world works, and I think that's why we are doing what we do, is because we get to like explore so many and almost scientifically how things behave.
But we don't have to write the papers at the end.
Yeah, that's
Yeah, no. And you have connections with Cambridge, don't you? Do you kind of have connections with the science going on there, or?
We tried to. I guess we like went over there and we had a contact there who was working with what's the kind of a crazy lab, like biomedical microbiology sort of stuff.
Yeah.
Yeah, super interesting to see the works, and I think that's something that we would really like to do, is really like get a foot in the door in one of the institutions and kind of be able to collaborate in some way. But yeah, I don't know, that one just didn't really take off.
Yeah, we went there for a talk, and like it was interesting to meet all the kind of academics.
Yeah.
And can confront those two worlds.
Yeah. There's quite a lot of like art and science commissions in the city, and yeah. See what's going on. Anyone else got any questions? I feel like I'm asking lots. I've got more. Rich, here we go. You've got a question.
I have a quick question. What hardware and software are you using to program this stuff? Is it like Arduino or something like that?
Yeah, so I guess the flickers and sinusoidal noise and I guess some pieces maybe in the future, we're trying to not use digital controls at all. The circuits are all independent little analog oscillators. So they're kind of like synthesizer circuits, I guess, but like act in a way that they behave the way we want.
So it's almost clockwork in a way.
What's that?
Almost clockwork in a way, but electric.
Yeah, exactly. Electrical clockwork. But like Honami, we would use, Arduino-based stuff to run the motors and a little computer to drive that. But yeah, as much as we can, we try to steer clear of software. I don't know. I really don't like using a computer too much to program stuff. So, I mean, we do that a lot with working with other artists, like doing consulting work and stuff. So if we can make our stuff as like hands-off computer as possible, it's good.
We're trying to get to find a way to have an sort of artisanal practice, but that's using, I guess, electronics and all these kind of crazy tech. But we'll get there.
Yeah, that's really cool.
I just want to watch you driving. You're home now.
Distracting, but...
And what about future ambitions? What do you guys want to kind of see going forward?
Depends a lot of the context, I guess. Ambitions have changed a bit recently.
Yeah. Survive.
Yeah. I mean, I guess lots of different things. As we mentioned, we would love to collaborate with more like, get a foot in the door in kind of academics, research, and more science projects. But also, we were quite like going into more like installation art and quite spatialized, big immersive installation. And then more recently, we've developed an interest in a smaller piece that we can put into a home, and I guess maybe that comes because of the lockdown, and and we want still to be able to share work like that. But there is an aspect in like what we do. We like this idea of like having something that's accessible and quite soothing that we can just put in a space in a room and enjoy. But also we care about sharing to a wider audience, and so I guess bigger commissions would be really interesting. So I don't know. What do you think?
Yeah, I don't know. I think at the moment it's like a combination of figuring out how we're going to survive in the future with the current climate, and that's partially driving this like building smaller, more accessible things we can put in someone's home. But I think we've got like a bunch of these ideas that we want to do.
Several bunches.
And we're just going to crack away at them, I guess.
Okay, my last question.
Okay.
And I'll probably think of more in the meantime. Is you mentioned Terrell, but I was just wondering who else you look at in terms of inspiration.
I would say Zimoun is a big one.
Yeah, Zimoun. Thomas Saracino.
Yeah. A lot of people from that.
What's the other guy? P.
Lang.
Lang.
Yeah.
For massive aesthetic modular kind of arrangement.
Yeah.
And Random as well, because that's obviously how we connected through Jen from
Oh
Random.
yeah, Random International. Yeah. I mean, I guess it's quite similar. They maybe use the aesthetics and they also use brass a lot, which is interesting. And it's interesting because they have also this kind of motive that all the surfaces that you design when you design, like you would like design them as if someone was going to see them. So they are like incredibly cautious with how they design things, and I think we also care a lot about like having kind of raw materials, but like designing them beautifully no matter where they are in the piece. But I think I guess maybe identify more with maybe more like not necessarily artisanal, but like less digital or like less controlled artworks, I think, which is why I mentioned Zimoun, because it's things that we really, really care about how the randomness of the environment can create something on its own, and how we can sort of like harness it, like use it in like, I don't know how to like frame it in a way that we can show what's beautiful with that, like the beauty that it can create. But we're
not necessarily control.
Yeah, we're quite scared about like control. Like you can very easily, once you have all these tools with technology, you can very easily control the whole piece, and then it kind of falls into the uncanny valley of kind of motions that are very controlled, and sometimes we feel like we're getting close to that edge, but that's why we try to.
Oh, another one. I guess like there's this Dutch kinetic sculpture dude, Zorro Feigl.
Oh, is it the beach guy?
No, it's this guy Zorro Feigl. He makes like these kinetic sculptures which are pretty much exactly what Marguerite was just talking about, but with mechanics. So he'll find like a mechanical phenomenon that's like counterintuitive, and he just finds it by playing around with big motors in his studio and chains and tires and ropes and stuff. And then he'll frame it and present it and show it, but he doesn't have any control over it, it'll just be like a spinning chain and like massive industrial motor that throws a rope somewhere and that makes a cool sound or something like that. I think that's.
And sorry, I've thought of one more question. What about maintenance of your work? Is that a thing that's quite tricky to deal with in terms of if you are making things for people's homes, say, or I don't know, it's like with things, do you have to kind of design it in, like bring it into that design process, or how do you kind of deal with maintenance as an issue?
I think we're not at the stage yet where we've had something in someone else's home for long enough to like know that it's gonna blow up or whatever. But with electronics, like we try to make things with components that we know work, and we test them, like run them for days on end in the studio. And it's kind of like a crash testing kind of thing. But with anything mechanical, like the maintenance is, you're kind of doomed, right? Like everything's gonna fail at some point, and
so that's why I wanted to develop this small mechanical artwork that's only pendulum, because it cannot, like, there is no bearing, no friction.
Yeah.
It's just you can touch it, nothing's going to happen. And then on the electronics part, then if it's very simple and analog, then less risk of there's no software crash, there's no software to be updated.
Yeah, it's future-proof in a way
Yeah.
because you don't need to have a Windows like 95 computer to program your artwork that you made ages ago. Or whatever.
But I guess it's
Yeah.
to let's see what happens because we're still quite young, so we haven't had the opportunity to like put an artwork in someone's room for a long time and see what happens.
Yes.
But we're working on developing small little lamps, and we're hoping to giving them to a couple of people to test how they interact with it and see how it lasts in the long term.
We have one here.
Yeah,
Nice, cool.
we can't go to them.
Well, if you ever need test people,
We do.
I guess also with some like kinetic works and light works, making them really beautiful objects, regardless of if they're on or off or moving or not, or kind of that's quite nice as well, isn't it? To have like the old Italian kinetic works that some of them don't actually move or do anything anymore. They're static objects because they have. Although I once went to a fancy gallery in Mayfair and walked around for like 45 minutes looking at all the kinetic works, and they were all off. I just thought they weren't moving.
Oh.
Looking out, the gallerist asked if I wanted them turned on. I was just too embarrassed. You know, when you go to those kind of galleries where you feel a little bit kind of, they're quite fancy and you feel a bit.
Yeah.
I wanted a price list. No chance. But yeah, they were really beautiful objects in their own right, regardless of. Actually, I probably enjoyed them as much when they were static as when they were moving or activated. So it was kind of interesting to get that double experience, really, of them. So.
Yeah.
Rich, do you have another question? You're unmuted.
I was just imagining, like, in the future, someone might find a dusty old little contraption you've made and they might know a bit of electrics and manage to jury-rig it back working again. Should be quite cool.
Yeah.
So it might last a long time.
Yeah, I mean, we've been thinking about this for a while, actually, like the longevity of any electrical thing. Like most components will, I think, capacitors, for example, might last 20 years, I think. And that's like pretty long. That's a decent
Especially
amount.
if it's that sort of clockwork kind of thing, where it's just components and
Yeah,
you're not relying on the software.
Yeah.
It does seem like it's got more longevity that way.
yeah, totally.
But it's not, it's still so short compared to just like a static sculpture or a painting. Like
That's forever.
hundreds of years, like forever. I mean, colors can fade, but it's,
But I think permanent, in terms of public commissions, the idea of permanent is 20 years.
Is it?
So, yeah. So, like, build in a maintenance contract for up to 20 years and then it's fine.
All right.
Although, I don't know, that's kind of a contentious issue as well if they're calling it permanent. And I guess 20 years is quite a long time now, isn't it?
For a long time. Yeah, good enough.
Not as long as you think.
I think it would be in 20 years' time, it'd be like super old.
It goes really fast. Sorry.
Yeah, probably. Any last questions from anyone? Okay, brilliant. If everyone could just unmute their microphone, or anyone who's able to, and we'll just give kind of a massive round of applause. Thank you so much for speaking for us today. Hello.
Recording.